Yes, class. Am I audible to all of you?
Yes, ma'am.
Yes, ma'am.
Arisha, this is your first class, right? Arisha.
Yes, ma'am.
All right. So, Arisha, see, first lesson, no, dimensional analysis, that portion of your unit 1 that we have already completed. So today, it's good that you have joined it today. We are starting with a fresh new lesson only. Now, see, before starting with your mechanics, all of you, before starting with your mechanics, firstly, I would like to discuss the calculus, mathematical physics part. Those who will be having maths, they'll already be learning this in class 12th, I think. But whatever calculus is required here in physics, that I'll discuss. All right. Now, see, in calculus, no, you have two functions basically, which you have to remember and learn. So one of the functions, this is differentiation. Second one is integration. So this will take a lot of time, a little time this will take, and we'll also devote time to it so that at least the basics is clear, and then we'll move on to motion in a straight line. Now see, I'll start with differentiation today. Integration we'll do it later. What is meant by differentiation, or what is the basic mechanism of differentiation? See, differentiation is when you are having a very small quantity with you. All right, something, just related it this way. I'm having a very small quantity with me and I want to find out the other portion. For example, in this figure, which is written on the screen, this is a rod. The length of the rod is L. Now, a very small narrow portion, if I take from this, let's say this is a very, very small portion that I have taken, which is dx. All right. And the entire length of rod is L. So if this dx is very small. Very small doesn't mean it's 2, 3, 4 meters. No, it's very small. It is infinitesimally small. We have a word infinitesimally small. This means what? When the quantity is very small. If suppose I take the value of dx would be somewhere near 0 point. Keep on adding this much 0 and 1, this much small. So this amount of quantity, if you have 0.00001, then we say the quantity is infinitesimally small, right? So see, if I take this one portion dx from the entire rod, suppose this is the rod and I have taken a very small portion dx, right? And I keep on adding all the dx which are present. Like this, if I keep on adding all the dx which are present, what will happen? Ultimately, I'll get the length capital L back, right? That is what is meant by differentiation. See, it's not easy for us not to add all the values of dx. Can you add the 0.0001 plus 0.0023 plus 0.0089 like this? How much can you add? So these are so many in numbers, these small dx, very, very small, minute portions, which we call as the best term that we use is infinitesimally small. So if these many portions, if we have from it, right, if you keep on adding it, so actually differentiation is addition of all these dx. But see, definitely you cannot add it using your algebra. So the specific function we have, that which we call as differentiation. Just some certain steps are there, basic rules are there which have to be followed, and once these rules are followed, then what happens? Finally you get the ultimate length back. This is just an example. We have so many quantities which we differentiate and find out, which we integrate and find out. That you'll see all the physical quantities will come in your lesson only. For example, one example I'll give you. You will study velocity. So velocity is dx over dt, mainly dx over dt. Now, why have I written as dx over dt? Suppose dx is length, dt is a very small time. See, quantity can be anything. It need not necessarily be length only. If I take a very small amount of time, 0.000001 seconds, such a small amount of time, so that becomes dt. So this is how we represent in differentiation. Now, when I say something is getting divided like this, you're saying, no, dx is getting divided by dt. So this means x is getting differentiated with respect to t. x is getting differentiated with respect to t. How to identify whether x is getting differentiated? See, Arisha, when we start the mechanics lesson, motion in a straight line. So before that, you have to have the idea of mathematical physics, of calculus, which involves integration and differentiation. So prior to the lesson, motion in a straight line, because this integration and differentiation will be used in your entire physics till your class 12. That's why we are studying it in the basics of physics. So you can say this is a part of mathematical physics before starting with motion in a straight line. Fine?
Yes, teacher.
All right. Now see, when I say dx over dt, this means x is getting differentiated with respect to time. Means you are differentiating, you are elongating. Technically, you can say you are adding all the dx with respect to time. So you should, I think all of you must be having this idea. For example, if I give this equation, y is equal to 2x. If I put the value of x as 1, I am getting value right. If I put the, see, I am values are getting changed. So what type of variable is x? We call such variables as independent just a second. My voice is not coming to all of you. Or is it fine?
Yeah, no, it's fine.
It's fine, ma'am.
It's fine, ma'am.
Okay. If it breaks, no, please let me know. Just text me in the chat column. So this is independent variable because this value you can modify. And the value which is now getting modified or changing by itself, that becomes the dependent variable. Right. So we just use the concept of this independent and dependent variable. So it's like change in the dependent variable with respect to the independent variable. Or you can directly remember this statement if I'm writing dy over dx. This means differentiation of y with respect to x. All right, understand basics laws that we have. So this is what is meant by differentiation. But how do we differentiate? What is the process of differentiation? This we have understood that yes, so many small quantities are present, and to add all the small quantities we differentiate, right? So how to differentiate? For example, this is a polynomial function given to you, y is equal to x to the power n. And most of the questions will be having y is equal to x to the power n only. N can be 1, n can be 0, n can be any number, 2, 3, 4, 5, any number. So y is equal to x to the power n. How to perform differentiation? Please class understand this very well. Suppose I have to differentiate this y with respect to x. This is what we have studied, no? The change in dependent variable with respect to independent variable means change in y with respect to x, that is dy over dx, differentiation of y with respect to x. That's why I'll write dy over dx. Now d means the differentiation symbol only, that I am differentiating this quantity, particular quantity, with respect to x. Now what is the value of y here? Y's value is x to the power n, right? In one step you will have your answer. That is, take and bring the power out. Bring the power out of the number, out of it. So just multiply it with whatever is the power. No, just multiply it with it. So power is n. I'll multiply this whole term with n. Fine, n, x to the power n. Now just don't stop over here. Subtract 1 from the power. That is minus. That's it. This is what is your entire differentiation. I'll give you one more example. See, this is a proper example. Y is equal to x to the power 2. Now, how to differentiate this? What did I say? When you are differentiating dy over dx, means dx square you are differentiating with respect to x. Whatever is the power that comes out, means 2 will come out from this x square, right? And now don't stop over here, just subtract 1 from the power. So what is left? 2x to the power 1, or you can say 2x. So differentiation of x square will give you 2x, right? Suppose coming to this example, y is equal to x cube. Now look, if I differentiate this dy over dx, this becomes dx cube over dx. So see, what is the power that is given? 3. 3 will come out and get multiplied. Nx we write, no, nx. So this becomes 3x to the power 3. And do we need to stop here? We have to subtract 1 from the power. So that becomes 3x. 3 minus 1 is 2. So answer for this is 3x squared. First, tell me, this part is clear to you? The basics mathematical part, how to solve it, what is the meaning of it? Clear by all of you?
Yes, ma'am.
All right.
Yes.
So do one thing, note it till here. We'll see the
Ma'am, is that V or U?
this is V.
What does WRT stand for?
With respect to.
Done, ma'am.
No, I'm done.
Now see some more questions for practicing. So suppose y is equal to x to the power, this we have done. The answer will be 3x, 3 minus 1, that is 2, 3x squared. Let's try this part. So we are differentiating dy over dx. That is, we are differentiating mainly this x to the power 5 by 2. So what is your n now? 5, see the standard form is x to the power n. What is n right now? This entire term is n. And how do we write it? Nx to the power n minus 1. This is the formula for it. So nx, n will come, that is 5 by 2, x to the power n minus 1, that is 5 by 2 minus 1. So what does this become? 5 by 2, x to the power 3 by 2, right? Come to this part. Again, we are differentiating dy over dx, so that becomes dx to the power half, which we are differentiating with respect to x. Now, see, nx to the power n minus 1. So n is half, x to the power n minus 1. That becomes half x to the power minus 1. This is how we perform differentiation. This is the basics of differentiation. Now, if you have understood this, most of your questions of wherever differentiation is required the differentiation will be required till your last lesson of class 12. So this is not just a topic for motion in a straight line or one particular. This is the basics of physics. Fine. So if you have understood this basic part, you'll be able to solve most of the questions. Just some properties are needed that I'll discuss it. The properties and some other cases if comes. Trigonometric values are given, exponentials are given, log values are given, then how will you handle? So that I'll discuss. First, note down this page. No need to write the first part, this you have written, second and third part.
Done, ma'am.
All of you have completed?
No, ma'am,
Yes,
I'm done.
ma'am.
Yes, ma'am.
All right. See, one more example, x is equal to t to the power 3 by 2. Before we move on to the property, see, just class one thing, because we were just doing no y is equal to x to the power something, y is equal to x to the power something. So if a different variable comes, you should handle it in the same way. See, now we are differentiating dx over dt, right? Now this is the independent, this is the dependent variable, this is the independent variable. So this is dx over dt this time. Now look, the way we write no n x to the power n minus 1, your n this time is 3 by 2 and x is t, right? This x is t. So nx, that becomes 3 by 2. X here is t to the power 3 by 2 minus 1. So what will it become? 3 by 2t to the power half. Fine, like this we write nx to the power n minus 1. X need not necessarily be x only. When I say x, it's the variable. It can be t, it can be y, it can be z, any variable which you are talking with, any physical quantity which you are depicting, that you will see through the question. That is not of your concern right now. Right now, you should just know if a variable is given with certain power, how to solve it. Fine, this you can note it later. Just see the applications. See, you have a concept of instantaneous velocity. You have formulas for acceleration. You have formulas for angular acceleration, linear velocities, angular velocities. So many quantities you have. Now, see, for all these quantities, no, you differentiate because why do we differentiate? See, formula of speed, all of you must be knowing, and all of you must have studied in your class 9th also. These things get repeated, have occurred in class 9th also, right? But see, difference that comes in class 11th is that in class 9th, you will just have been given a particular distance. You will have a particular time, and you will be asked to calculate out the velocity. In class 11th, you will not be just given a particular time or a particular distance. Questions can be modified in the manner that you will be asked to tell the velocity exactly at, let's say, 0.0054 seconds. Then what you're going to do? You cannot even round it off, right? So if you have 0.0054 seconds, at that particular instant, you have to calculate the velocity and the distances in variable form. That time we perform differentiation. Same thing is for acceleration, and so many formulas you have that you do not worry, do not even remember this right now. This is not of use. As soon as the chapters will come, you'll have to remember this in every lesson. So by practicing that, you will be able to learn all the formulas. Suppose a trigonometric function comes. See, it can happen in some of the questions can have the values of trigonometry, out of which are very common. Class, this sine, cos, and tan. Especially the sine part and the cos part. These both you have to remember. Also tan, try to remember tan. Others, even sometimes they are rarely given in, and usually given in tough questions, but mostly in your basic questions also sine theta and cos theta can be involved. Here, instead of theta, I have written x. I think, let me write it theta so that this becomes clear that I'm talking about angle. Otherwise, this will become confusing. D sine theta will be plus cos theta. Suppose I have sine 30 degree. So when I'll differentiate sine 30 degree, I'll get cos 30 degree. But if I am differentiating cos theta, I'll get negative sine theta. This is easy to remember. At least this part you can remember. If it is tan theta, you get sec square theta, right? So tan theta also can be used in some question if it is given, just in case you should remember. But sine theta and cos theta, you will be having questions. In your projectile motions, in your rotational lessons, you will be having questions. And then this also, let me write theta only. So if you are differentiating sec theta, or if you are differentiating cosec theta. So sec theta and cosec theta are usually not given in the exams. But if somewhere you find a question, you should have the knowledge how to differentiate these. So this is sec theta becomes sec theta into tan theta. Cosec theta becomes cosec theta into cot theta. Similar is the case for this also, cot theta also, which is the inverse trigonometric function. All of you must be having trigonometry just in your class 10th exam. So you must be remembering this. This is cot theta, sec theta into tan theta. This is how we write this. So these are the basic trigonometric functions which you should remember, out of which sine theta, cos theta, and tan theta. At least sine theta, cos theta, you should remember this will be used. This is going to be used, especially in your projectile and rotational motions. So just remember these things. Exponential, I'll tell. First note it down till here. And whatever doubts you're having, get it clarified. Either you can unmute yourself or ask me, or the best method is just type your doubt in the chat column. So only I'll be reading your doubt, whatever doubts you have. Note it down.
Done, ma'am.
No,
Yeah, ma'am.
these are not. This is for sec theta. This is actually minus cosec square theta. This is for cot. You just make a correction. By mistake, I had written for sec theta. You just make a correction, class.
Done, ma'am.
All right, class. Now see if you have an exponential function or a logarithmic function. So these can be given to you whenever you have exponential function. Now I hope all of you must be knowing what is this exponential. The way we have no pi. Value of pi is fixed 3.14 something something. This is a finite fixed value. Similarly, you have exponential. This value is also 2.14 something something and fixed value. Exponential means when something increases abruptly. This is the graph, or something decreases abruptly. So exponential graph is this graph. Y axis, x axis, this is it. So if you are getting no differentiation of exponential function, after differentiation, even when you'll differentiate dx over dx, dex over dx, this will be exactly same, no change in differentiation. Suppose you are having logarithmic function, log table. So just in case if this is asked, these are just extreme questions if it is used. For ln x, you will get in this form only. Natural logarithm present is present, and other one is log table, which you get. So ln x is present. If you differentiate, no, you just write the reciprocal of it, 1 by x. ln x, so differentiation of it, dy over dx will become 1 by x. Suppose ln 5 you have. So on differentiation, this will become 1 by 5. That's it. This is just what you have to remember. Now see class, if suppose no, you are getting a constant function. Suppose k is a constant term. So on differentiation, this will be 0. Suppose I give you just 3. No 3x square, no 3x, no 3x plus 5 like this, nothing, just 3. 3 is a constant term. So when you will differentiate dy over dx, this will become 0. Or pi is also a constant number. You know its definite value. This definition is fixed. So dy over dx for pi, this will be 0. If you're having just a constant function. But if I take both the constant and variable together, then how will I solve? Suppose x square is the variable. We have been solving it like this only: x square, x cube, y is equal to x square, y is equal to x cube, y is equal to x to the power 5 by 2, like this. Any constant, always. Yes, Arisha, for any constant, anything that is mentioned as constant. Suppose I give you a number, just alphabet also, no, a, and I tell you that this a is constant. Differentiation of a will be 0. But just the difference is that now this has to be independent. No variable shouldn't be around it. Suppose we have been solving all the questions like this, no, y is equal to t to the power half, y is equal to x to the power 3 by 2, right? Like this we have been solving. So suppose if you are having a constant and this variable together, then how will you solve? Variable we have learned it together, that will be nx to the power n minus 1. Constant also we have learned that it would be 0. But if they are combined together like this, k is the constant over here and fx is the function. Means you are differentiating like 3x square. So in this 3, now 3 is a constant term and x square is a function. So you have such a case, 3x square. In such cases, what you do, keep the constant term with you, whatever is the constant term. 3, here is the 3 is the constant term, or k you are having. Let me talk about first this k in terms of this. When you're differentiating this, keep k as it is, just multiply it, and x, function of x, you have seen how to solve it. Now differentiate this function of x the way you have been performing differentiation and multiply. For example, if I have 3x square, if I am differentiating dy over dx, 3 I will keep, just keep it as it is, the constant term. X square, we have studied how to differentiate x square, 2x to the power 2 minus 1. Nx to the power n minus 1. So 2x to the power 2 minus 1, that is 2x. Now multiply it directly the way you multiply 6x. Solved? Or let's come to this, 4x cubed. See, if I am differentiating dy over dx, 4 is the constant term, keep it, multiply it at the end. X cube, how to solve x cube? X to the power n we have seen, that is nx to the power n minus 1. What is n? N is 3 x to the power n minus 1. That becomes 4 into 3x square, that is 12x square. This is the answer. Clear or not till here? First tell me, class. Clear? So note down this part from here. Any doubts you have, let me know. But that constant term, all the properties one is important. This is not so important because these are given in very rare questions, in difficult questions, most of them. But these properties, these are important till here.
Ma'am, could you scroll?
See, if you are having a particular number, then that will be a constant term, right? 3, 4, 5 term number is there, or any fixed value like pi or something that is already known whose value we write. Otherwise, in the question, no, if A, B, C, D or any term is constant, it will mention you in the question that where A and B are constants like this. Just text me done class once you have written till here.
Ma'am, I'm done.
Yes, ma'am, I'm done.